Welcome to the series of lectures in C language. This is Saikiran, Assistant Professor in Department of Computer Science and Technology from Madanapalle Institute of Technology and Science. In our today's lecture, we will discuss about operators in C language. So what is an operator? So basically, an operator is a symbol which is going to be used between the operands in order to perform a certain operation. So first, let me give the definition here. As I discussed, it is a symbol which is used between operands to perform an operation. Here, each operator will have specific meaning and functionality. Will have specific meaning and functionality. In C language, we are having 7 different types of operators. So let me categorize all the operators here. The first category of operators will be like arithmetic operators. And second category is assignment operators. And third category are relational operators. And fourth one is logical operators. Fifth one is increment or decrement operators. And sixth one is conditional operators. Seventh one is bitwise operators. And last category we are having like special operators. So these are the different categories of operators which are available in the C language. Now we will discuss about all these operators one by one in detail. First we will discuss about arithmetic operators. So these arithmetic operators are used to perform the arithmetic operations like addition, subtraction, multiplication, division and modulus division. So in order to perform these operations, for each operation we are having a specific operator. So basically these are used to perform arithmetic operations. So here the arithmetic operators are plus, minus, star which is going to represent in the multiplication, division operator and then modulus division. So here this operator is a used to perform the addition and this operator is used to perform the subtraction and this operator is used to perform the multiplication, and this is going to is performed to perform the division operation, and this is used to perform the modulus division. Here this division operator will give you the quotient value, and this one will give you the like remainder value. Quotient value and remainder value. Now we will see the next category of operators, which is the assignment operator. So before going to the assignment operator, let me show one example program by using all arithmetic operators. We write the header file. So here I am taking two variables int a comma b, okay, and whose values I am going to assigning in a dynamic way, which we discussed in our earlier lecture, like how to initialize, and even we have seen how to use the input and output statements. Everything I am going to using here. Asking enter a value, and I am reading that value into the variable a, scanf percentage d comma ampersand a. I am going to read the next variable value printf enter b value scanf percentage d comma ampersand b. So let me take one more different variables which I am going to use to store the values of all the operations. So here when you are coming to the arithmetic operations, we have seen like addition, subtraction, multiplication, right? So in order to get the result from each operation, the result I want to store in a separate variable. For that purpose, I am declaring the variables here. Add variable I am using for addition, sub variable I am using for subtraction, mul variable I am using for multiplication, division variable I am using for division operation, md is for modulus division. So let me write the operational statements here one by one. So add equal to, let me take a plus b, and sub equal to a minus b, mul equal to a into b, and division equal to a by b, and modulus division equal to a mod b. So after performing all the operations, I want to print the result on the screen. Let me add the printf. I am going to use a single printf only to print all the values here. If backslash n addition equal to percentage d backslash n subtraction equal to percentage d backslash n multiplication equal to percentage d backslash n division equal to percentage d backslash n modulus division equal to percentage d. Now let me call all the variables here. The addition value is available in the add variable, add comma sub comma mul comma div division comma empty. Let me compile the code gcc space dot c. So my code is compiled successful. Let me run it. Dot out. So it is asking me enter a value. A value I want to give like 5, and it is asking me to enter the b value. Let me give b value like 2. Now you can see the addition value of a and b. 5 plus 2 is 7. Subtraction is 5 minus 2 3. Multiplication is 5 into 2 10, and division is 5 by 2. I already told it will give the remainder value. So that's why we got like 2, and modulus division for division it will give the quotient value. That's why we got 2, and modulus division is going to give the remainder value. That's why we got 1. So this is about the arithmetic operators. Now we will discuss about the assignment operator. So basically, assignment operator is used to assign a value to a variable. So here the assignment operator is equal. It is used assign a value to a variable. The operator is equal. So assigning a value, we can also call it as a initializing a variable. So let me take one example for this. For example, I have taken one variable int a. I want to assign some value to this variable a. So we can assign the value like a equal to 10. So this is the example for using the assignment operator. So here we are having one more variation in the assignment operator, like compound assignment. So basically this compound assignment can be used along with the arithmetic operators and bitwise operators. So let me give the notation how this compound assignment operator will be used. So the compound assignment operators will be like plus equal, comma, minus equal, or multiplication equal, otherwise more division equal, and modulus division equal. So this is the way how we can write the compound assignment. So basically this formation we can write like when you are having the expression like a equal to a plus b. See, when you are having this kind of notation, this expression can be rewritten by using the compound assignment operator. So it will be like a plus equal to b. So this is how we are going to write the compound assignment operator. Next, we'll move to the next operator category. So after assignment operators, we have taken the relational operators. So these relation operators are used to identify the relationship among the different variables. And these relation operators are also called as comparison operators. These are used to identify the relation among operands or variables. So the relation is nothing but here like greater than or equal, or less than or equal, whether both are equal or not equal. So this kind of relationship we can identify by using the relational operators. And as I told you, these relational operators are also called as comparison operators. Operators. Okay. So the relation operators are like greater than, less than, greater than or equal to, less than or equal to, equal to, and not equal. So these are the different relational operators. Greater than, this one is less than operator, this one is greater than or equal, less than or equal, and this one is called as equality. Equality operator, and this one is reverse to the equality, not equal. So here you can observe like for assignment operator we are having only single equal, and for equality operator we are having double equal, right? So most of the people will get confused here. The single equal will be used to assign a value to a variable. For example, let me take a equal to 10. So here we are assigning 10 value to the a variable. If I am writing a double equal to 10, it indicates that we are comparing the value of a whether it is equal to 10 or not. Clear? So this is the like one important question what we can expect for interview purpose also. So here these relation operators are going to return only Boolean value. It is going to return only Boolean values. So Boolean values are nothing but either true or false, either true or false. So true will be represented with 1, false will be represented with 0, and false will be represented with 0. So let me take one example here. We will write one example program for this relational operators. Yes, space C hash include h. I'm taking two variables int a, which value I'm taking like 20, and b variable I'm taking whose value I'm taking like 10. Now let me print the values of all these relational operators, how they are going to be used. Percentile D, comma, A greater than B, comma, A less than B. A greater than or equal to B. Percentile D, A less than or equal to B. Printf percentile D backslash n, comma, A double equal to B. Printf percentile D, comma, A not equal to B. We will see here what is the output we are going to get here. Let me compile the code. GCC relation dot C. So I have used print somewhere. So the output statement will be like printf, right? But here I used a printf relation dot C. So here my code is compiled successfully. Now we will see the output what we are going to get here. Here you can observe like 101001. So here the A value is given like 20 and the B value I have given like 10. The first operation I have written is A greater than B. So A is greater than B, that's why we got the value 1. This 1 indicates true, right? And next operation I have written like A less than B. A value is 20, 20 less than 10, false only, that's why we got 0. And next one is A greater than or equal to B, that's why we got 1. A less than or equal to B, 0 we got. A double equal to B. A value is 20 and B value is 10. Both are not equal, right? So when I'm using equality operator, it is returning false. When I'm using not equality, yes, A is not equal to B. It is true only. That's why we got 1 here. So this is about the relational operators. Next category is logical operators. So here, these logical operators are going to be used between the different expressions. So when you want to compare the different expressions, then we are going to use the logical operators. By using these logical operators, we are able to form the complex expressions. For example, I'm having one expression A greater than B, and I want to find the relation between this expression and another expression like B greater than C. In between these two, we can use the logical operators, and these logical operators are also going to return only Boolean values as a result, either true or false. And the logical operators are logical and logical or and logical not. So these are the symbols which are going to using to represent the logical operators. So this is logical and this one is logical or, and this one is logical not. So here this logical and will return true when both the expressions are true. Here, this will return true when both the expressions true, otherwise any one of the expression is true. Otherwise it will return the false. When both are false, it will return the false. So here, this one is going to return like if the expression value is true, then it will give you the false. If the expression value is false, then it will return the true. So based on the value of the particular expression. And the next category, first we will go to an example program for this logical operators. Then we will go to the next category of operators. Void main. Let me take three variables, int a equal to 10, b equal to 20, and c equal to 30. So these are the values which I assigned to the variables here. Let me write the statements. Printf percentile d comma. So here I am writing the conditions here. A greater than b and b is greater than c. So this is the statement what I have written here. Okay. Next one, writing printf percentile d comma. I am writing a less than b or b greater than c. Okay. Next one, printf percentile d comma not of a is greater than b. If you observe here, I have written a greater than b here, right? What is the a value? 10 and b value is 20. A greater than b means it becomes false, and I have written b greater than c. B value is 20 and c value is 30. 20 greater than 30 means false. Both are false, right? False and false. In this case, this particular logical AND operation is going to return the value false only. So which is going to represent it through 0. Now in the second statement here, I have written a less than b. A value is 10 and b value is 20. So 10 is less than 20 true, or b greater than c. B value is 20 and c value is 30. 20 greater than 30 false. True or false, in this case it should return true only. So as I discussed, the logical operator will return false when both the expressions are false only. But here in this example, here one is true and another one is false, right? So obviously it should return true only. And next one is a greater than b, not of a greater than b. So this a greater than b is going to return the false. Not of false means it should return true. Here we will see the output here. Let me use backslash n so that we will get the output in in different lines, not in single line. Let me open it. Why? Because here I written print statement. Here it should be like printf. Okay. So let me compile the code. GCC space logical dot c. My code is compiled successful. Let me run it. Dot slash a dot out. You can see the value 0, 1, 1 as per our discussion. Now let me move to the next operator. So increment or decrement operators. So here this increment and decrement operators are used when you want to increase the value of a variable by 1 as well as when you want to decrease the value of a variable by 1. In that case we are going to using this increment and decrement operators. So these are used to increase or decrease the value of a variable by 1. So here the increment and decrement operators are plus plus and minus minus. So plus plus will be the increment operator and minus minus is decrement operator. Here these increment and decremented operators can be used in two different ways. One is pre and another one is post. So we can see the differentiation of this pre and post increment as well as decrement operators when you are using them directly in the printf statement. So here what do you mean by pre and what do you mean by post, that you need to understand here. These operators can be used as pre as well as post. So let me give one example for this. For example, so for pre increment, for example, if I am having a equal to 10, if I am writing plus plus a, then the value what we are going to get for this statement is 11. Here the value of the a first will be incremented by 1, then it is going to be used in the operation. If I am having something like a plus plus, it is called as uh, post increment. So here plus plus a is the example for pre increment, a plus plus is the post increment. So in this case when you are using it, first the value of a will be used and then the a value will be incremented. Okay, finally the a value will be incremented, but before increment the value will be used in the operation. So that we can see the differentiation when you are using them in the printf statement. We are going to illustrate through an example program, don't worry. And pre-decrement will be written like plus plus a, and then here like post decrement will be like a minus minus. Now we will see the working behavior of this pre and post increment and decrement operators through an example program. Let me take two variables, a equal to 10 and b equal to 20 I am taking. Now we will see how these uh, increment and decrement operators are going to behave in terms of pre and post. Percentile d, comma, I'm using a plus plus. We will see it here. What is the output we are going to get? I will explain again one more time. Percentile d, comma, plus plus a. Percentile d, comma a minus minus del d comma minus minus a. So here let me write one. Let me print the value of here percentage d comma a value. Let me print here so that you will understand how it is going to behaving there. Let me take it here b not a. Printf percentage d comma b. Also let me take it like b. Now we will see here. See the example here. So here a value I have taken like 10, and in the printf statement I am using a plus plus. In this aspect first a value will be used. So now for the first printf statement it will print the value 10 and then the a value will be incremented. Now when I am trying to print the value of a, it is going to give me 11. Now when I am using plus plus a, here first the value will be incremented. So as the a value is 11, it will be incremented first and the value will be printed. So here we are going to get the 12. So same behavior will be applied for the decrement operation also. Sorry, I written the semicolon statement inside. Okay. Semicolon I have written inside. Now my code is compiled successfully. Let me run it. So here you can see, like I didn't use the backslash and that's why we got all the values in a single line. Let me use the backslash n here so that all the output will get line by line. So when I'm using backslash n, the output will be displayed in the new line, right? So we need to compile it as we have done the modification in the code. Let me run it. Now you can see the output. So what is the a value given 10, right? So I have written the first statement like a plus plus. So which is nothing but the post increment. In the post increment, first the value will be printed, then the value will be incremented, right? So that's why when I'm printing, when I return the next statement to print the value of a, there we got 11. Third one is the pre-increment. That's why we got 1. So next statement I have written like post decrement. That's why the b value actually printed as it is 20. And then when I'm printing in the value of b, then we have seen the value which is decremented by 1, right? 19 we got. And last one is the pre-decrement. That's why the value is decremented first and then it printed. It got printed, right? So this is how the increment and decrement operators are going to be used. So we'll move to the next category of operators, conditional operator. So this conditional operator is also called as ternary operator. Ternary operator. Okay. So here the conditional operators are question mark and colon. So this question mark is going to work like a if statement, and this colon is going to work like a else statement. So basically this question mark and colon, why we are going to call as a ternary operator means this will be used between the three expressions. That's why we are going to call conditional operator as ternary operator. So let me give one example for this to illustrate here. Uh, I have taken two variables like int a equal to 10 comma b equal to 20. Now we will see I want to find the maximum number among these two numbers using the conditional operator. So how to write the statement? I'm taking max equal to, I'm writing a greater than b colon, sir, question mark. If it is true, give the value a, otherwise give the value b. So now is here I'm checking the condition a greater than b. Question mark, as I told you, like it is going to work like if, right? So if it is true, what I'm telling, a is the maximum value. So the a value will be assigned to the max variable. If it is false means, so that in that case b is the maximum value, that value will be assigned to the max variable. Now we will see the same example and we will do the execution part. Void me. I have taken two variable int a equal to 10 comma b equal to 22 variables have taken. I have taken one more variable max uh, where we are going to store the maximum value of between a and b. See how I am going to write the condition max equal to a greater than b. If it is true, a is the bigger number, else b is the bigger number. Maximum value is percentage x dash n comma max. Let me compile the code. This is c dot conditional dot c. Let me run the code. So you can see the maximum value is 20. So this is how the conditional operator are going to behave. Now we'll move to the next category of operators. They are bitwise operators. So here these bitwise operators are used to perform the operations at bit level. So generally when you are going to give a number to a variable, it will be represented in the decimal format. So here if you want to perform the operations at bit level between the binary codes, then we can use the bitwise operators. These are used to perform the operations at bit level. So here the bitwise operators are bitwise AND, next one is bitwise OR, next one is uh, bitwise NOT, and next one bitwise XOR, and then right shift, and then left shift. So these are the different bitwise operators which are available in the C language. So here this AND operation is going to work like a logical AND. For example, when both bit values are 1 1, then only it becomes 1. Otherwise it is going to return 0. Let me go one small example. For example, I have taken A value equal to 2 and B value equal to 3. Now this 2 will be represented in the binary format like 0010 in 4-bit representation, and this 3 will be represented as 0011 in 4-bit representation in the binary codes. Now when I'm going to performing the AND operation here, for A and B, the result will be like, you can see here. So the operation will be performed from the left to, so right to left. So 0 1, the value will be 0. Okay, and next 1 1, the value will be 1, and then 0 0, the value will be 0. So you are going to get two zeros. Okay, so this is the final result you are going to get here. So 0 1 0 1 1 1 0 0 0 0 0 0. So this is the value what we are going to get for 2 and 3. Suppose if you want to perform the bitwise OR operation like A or P, so it is going to be like a logical OR. So when both are zeros, then only it is going to return 0. Okay, in all the remaining aspects it is going to return 1 1. So the result will be like 0 0 1 1 you are going to get for A or B. Why? Because 0 1 1 1 1 1 0 0 0 and 0 0 0. So if I am taking like uh, not of A, so here this not operation is going to reverse the bit value. Suppose if the bit value is 1, then it is going to give 0. If it is 0, it is going to give 1. So now the A value will be in the binary format is 0010. When I am using the bitwise not operation, it is going to return 1101. Actually, the values won't be given in the binary format. After performing the operation, the resultant binary value will be converted into equivalent decimal number, and the value we are going to get is in the format of decimal number only. So when I am using the XOR operation like B, so here in XOR operation, when both are 1 1 and 0 0, then only it is going to return 0. So when the bit values are different, then it is going to return 1. So in our example, for 0 0, it is going to give 0 0 0 1. So for A XOR B, the result is going to be 0 0 0 1. Now if I am asking the right shift, so now here like when I am asking for the right shift of 2, the bit value of A will be shifted 2 position to the right. So here when you are going to representing the binary value for any decimal number, the right part is going to be the most significant bit, and sorry, we are going to have the least significant bit at the right side. MSB is going to be at the left side. So now here all the values will be shifted to the right, 2 position right. So what are the bits which are going to the LSB side, they are going to be discarded. So here right shift 2, we are going to get the value like 0 0 0 0 only. Why? Because these 2 bits will be shifted to the right side, right? What are the bits shifted to the right side? The 1 and 0 will be discarded. And equivalent operation will be carried for a left shift 2. So actually right side is LSB, list is going to be int, and right side left side will be like MSB. So now in this case, all the bit value will be shifted to two position to the left side. So as we are going to having the representation of a particular number, it may be 8 bit or 12 bit or 16 bit, 32 bit we are going to have. In that aspect, all the values will be shifted to the left side and the last positions are going to be filled with zeros. In this case, the value of A will be like 1000. Before this we are going to get the zeros only. Okay, so it depends upon how we are going to representing the number, whether it is in the 4 bit or 8 bit or 16 bit or 32 or 64 bit or 128 bit. Based on that, the values are going to change. And the last category of operators are special operators. So here these operators are going to have in the specific meaning. For example, ampersand. So this operator is going to be used to represent the address of a variable, and pointer operator, the same star is also going to be used as a pointer operator, and when this operator is also going to be used as a director. Okay, arrow operator we are going to using when you are going to using pointers with structure concept, and dot operator is going to be used as a membership operators. So these are the different types of operators which are available in the C language. So this is the reference textbook which I considered. If you are having any queries, questions about e-content and PPT preparation, kindly leave your queries here. Thank you.